Welcome students. Once again, I welcome you all to my video classes. Today, we will discuss one of the important topics from symmetry elements, that is group theory and symmetry groups or point groups. The title is point groups or symmetry groups. What is this point groups? What does it mean? How it is connected to symmetry elements? These are very important. And the questions are, you will be provided a molecule and you will be asked to identify point group of that molecules. So, to get the correct answer, you should have a very thorough knowledge about symmetry elements. I repeat once again, you can't do this part well unless your knowledge in symmetry elements is perfect. Therefore, I request you to watch all symmetry elements topics and learn it perfectly before going to these topics. Here, I introduce you a simple shortcut method to identify point groups of every molecules. And I will do lot of examples which have been asked in various examinations. Okay, let us go to the topics. First, what is point group? It's a group of symmetry elements. Okay, point group is a mathematical notation or denotation, mathematical notation or denotation to represent number and nature of symmetry elements possessed by the molecule. Suppose I say water, the point group is C2V. I say, looking at this point group, you can identify what are the symmetry elements present in water. Okay, if two molecules are in same point group, they have same symmetry elements. Therefore, it is a very simple idea to get or to assimilate the knowledge of symmetry elements, and it is a very simple idea to classify the molecules based on symmetry elements. It is very difficult to remember all symmetry elements of all molecules. It is difficult. But you can groups of molecules. I will say that H2O, H2S, H-tellure all have these point groups. Yes, therefore it is a very, very important idea. Identifying point groups is very, very important topics in the competitive examination. Okay, let us discuss how you can identify point groups in a shortcut method. Okay, now I classify point groups into three categories. One is C group, second one is D group, third one is special group. Special group. C groups are again different one. C1, CS, CI, CNV, CNH. D groups are following: DN, DNH, DND. Special groups: tetrahedral, octahedral, icosahedral. Icosahedral, IH. Okay. Therefore, these are our different point groups: C1, CS, CI, CNV, CNH, DN, DNH, DND, TH, OH, IH. Okay. Yes. You have C groups, D groups, special groups. Special group is special category, you remember always. Okay. These are the two important categories: C group and D group. Okay. What is the difference between C group and D group? C group has a CN axis. It has CN and NC2 axis. When axis of symmetry was discussed, I have mentioned what is this NC2. Therefore, C group has CN axis, only D group has CN and NC2. Okay? Yes. Fine. Now, we can discuss each group one by one. First is C group. C group. C group. You have a C1, CI, CS, CNV, CNH. C1 means it has only identity, that is C1 360-degree rotation only identity, nothing else. Okay, one example: C, H, F, BR, I. It has no plane of symmetry because it is tetrahedral. Remember, this tetrahedral, not TH. I will explain that. Okay? Not this. This TH group is, remember, special group TH is CH4, CCl4, CBr4, CF4 like that, or SiCl4 like that. What is this difference? Here all groups are different. Here all groups are same. If all groups are same and tetrahedral, that is the tetrahedral point groups. Okay? Here tetrahedral but all groups are different, then it has only one symmetry element identity, the first C1. It has, I said to you, every molecule has 360 degree. Remember that every molecule has 360 degree. Therefore here it has identity and center of symmetry. Center of symmetry. What is identity? C1 axis. Every molecule has C1 axis. And again I suggest to you, if you are not clear this idea, C1 axis for identity, please watch previous video. Okay, therefore it has center of symmetry only and a C1 axis. We will not mention C1 axis separately. Here it has identity and a plane of symmetry. Plane of symmetry. A plane of symmetry. I will give the example, don't worry. Here it has center of symmetry only, plane of symmetry only, it has identity only. All these have identity. Here it has Cn axis except C1. You have any other axis except C1. C1 already present. Here you have any other axis like C2, C3, C4 except C1 and NCV, N sigma V, that is 2 sigma V, 3 sigma V, 4 sigma V. Okay? Yes. Here you have Cn axis, that is C2 axis, C3 axis, C4 axis, and sigma H, 1 sigma H, sigma H, 1 sigma H. Student, you may ask me a question whether it has sigma V. Yes, it may have sigma V also. Sigma V also. But it is important. It is important. Okay. Therefore, trick number one. Once you identified your molecule is C group. How do you identify C group? Because C group means it has Cn axis only. No NC2. No NC2. This is not there. Therefore, you identify it is a Cn group. If you identified it is C group, then immediately you check whether it has sigma H. Sigma H. What is the second you have to check? Sigma H. Remember, first you look for Cn axis, then NC2, no NC2. Then third you check for sigma H. If it has sigma H, it will be CnH. If no sigma H, check for sigma V, then CnV. If it has not both these, it will be any of these category. Fine. Okay. Now we can go to D group. What is D group? What is D group? D group. D group has Cn and NC2. NC2. Fine. It has Dn, DNH and DND. What is Dn? Only Cn and NC2. No plane. Here Cn, NC2 and sigma H. Here Cn, NC2 and sigma D. No CNH. No sigma H. No sigma H. Therefore, here also you have to check if there is sigma H present or not. If there is sigma H, it is DNH. If there is no sigma H, it may be DN or DND. Fine, very simple. Okay, now special groups. What are our special groups? What are our special groups? First is TH, tetrahedral. Tetrahedral, I give you a lot of examples. CCl4, CH4, CBr4, SIF, CL4, etc. Octahedral, SF6, icosahedral. Very rare example, icosahedral. Look at here, all 6 atoms are same, all 4 atoms are same. Okay, simple. Okay, now how do you identify? How do you do the examples? There is a chronology of checking. There is an order of checking. Okay, let us first write our symmetry elements. C1, Ci, Cs, Cnv, Cnh, Dn, DNH, DND, tetrahedral, octahedral, icosahedral. Okay, these are the important symmetry elements. Fine? Yes. Now, what is the first you have to do? You check if Cn except C1 present. Check Cn except C1. Everything has C1, no doubt. Except Cn, you check if Cn is present. Second, once Cn identified, if NC2 present. NC2 present. Yes. If Cn and NC2, it is D group. Cn only, C group. Once you identify C group or D group, check for sigmoids. Third, check for sigmoids. Both case sigmoids. If sigmoids, it is CNH. If no sigmoids, then go to sigma V. Here sigma H is there, DNH. Now if no sigmoids, then D, sigma D. Therefore D and D, both are not DN. It is sigma V, not sigma H, then sigma V and sigma V. Remember, even there is a sigma H, there will be sigma V. Even there is sigma H, there will be sigma V. Therefore, which will check first? Sigma H, then sigma V. If both are not present, then it will be Cn or Ci or C1 or Cs. Okay, Cn axis. Here Cn axis. I'm sorry, Cn axis. Yes. Fine. If Cn is principal axis is 1, C1, there will be 360 degree, it will be C1. Then, as usual, I have said you have special groups, you remember as such. Now, trick for linear molecules. Tricks for linear molecules. What is a trick for linear molecule? Linear molecules, it may be D infinity H or C infinity V. The molecule D infinity H is completely H, the linear like this, okay, or N like this, or acetylene, okay, symmetric. That is, from the center you have identical groups. Spot a center, you have identical groups. But you have seed OS. Seed, okay. This is a center, no identical groups. But O double bond O belongs to this because spot a center, from the center you have identical DNH. And triple bond N. This is the center, from the center both sides are identical. If both sides are identical from the center, both sides identical from the center, then DNH. Both sides are not identical from the center, then C infinity V. This is for linear. If once molecule is linear, forget everything, focus here. Got it? If molecule is linear, forget everything, focus here. If molecule is special case, tetrahedral or octahedral, forget everything, go to that case. In all other case, you group them first C group or D group. Once it is C group, then check for sigma H. Or D group, check for sigma H. If sigma H is not present, go for sigma B. Fine? Yes. Yes, this is the videos for this class, and examples, I will do the example in next session. Okay, I will do all the example in next session. Watch the video and go to my example videos. Thank you for watching.